Magandang araw! I hope everyone who is watching this video is safe, healthy, and happy. Now, this is a presentation on naming alkynes. Alkynes are unsaturated hydrocarbons that contain a carbon-carbon triple bond with the general formula CnH2n-2. So the rules in naming alkynes are also based from the International Union of Pure and Applied Chemistry, where the general rules are similar to those used for alkanes and alkenes. Only this time we use the suffix -e or -ine. Numbering also begins at the chain end near the triple bond so that it receives as low a number as possible. So we have here on the screen examples of straight chain alkyne. No? The simplest alkyne is ethyne, which contains 2 carbons. So we have CH triple bond CH, which is ethyne, as I mentioned earlier, and is commonly called acetylene. So we have propyne, and then we have 1-butyne and 2-butyne. Notice that 2-butyne, the triple bond is at carbon number 2, so the locant is carbon 2. That's why we have 2 there from in the name. And 2-butyne is an example of an internal alkyne where the triple bond is located inside the structure of the molecule, whereas the other examples are terminal alkynes where the triple bond is at the terminal carbon or carbon number 1. Now, substituents containing a triple bond are called alkenyl. Recall our discussion on alkanes. When a hydrogen is removed from an alkane, we call the remaining group alkyl. For alkyls, the remaining group is called alkenyl. For alkynes, the remaining group is called alkenyl. So we have ethanyl, we have propenyl, and then 2-propenyl. Note that the carbon attached to the parent chain is always carbon number 1. So this is carbon number 1, 2. And that's why this is called 2-propenyl, because the double bond is at carbon number 2, considering that carbon 1 is always the carbon attached to the parent chain. So we have some more examples. So we have 2-pentyne, where there are 5 carbons, and the triple bond occurs at carbon number 2. And then we have octyne. So there are 8 carbons. And we start numbering here. So we have 1, 2, 3, okay, and then a methyl substituent at carbon number 6. So we have 6-methyl-3-octyne or 6-methyl-oct-3-ine. So notice that this is one word. The number 3 here is where the triple bond is located, and the 6 refers to the carbon where the methyl group is attached. We could also have multiple triple bonds, as in this case where there are 10 carbons or decyne, but since there are 2 triple bonds at carbons 1, 2, 3, 4, 5, 6, 7, so we have a 3,7-decadiene or deca-3,7-diene. Now, what happens when double and triple bonds appear in the same molecule? Now, a double bond and a triple bond have the same priority. Now, that molecule which contains a double and triple bond is called an alkyne. Okay? The chain can be numbered starting with the end closest to the functional group, whether it is a double bond or a triple bond. And in the name, in comes first before ine, simply because it appears first in the alphabet. But we drop the last letter E, so we just have N to denote that the molecule has another functional group, which in this case is a triple bond. So we have here, we start numbering here because this is the carbon where the triple bond is attached nearer this carbon. So this is carbon number 1. And then the methyl, the double bond is at carbon number 7. And the methyl group is attached to carbon number 4. So we have 4-methyl, 7-nonen, 1-ine, or 4-methyl-non, 7-N, 1-ine. Here we have how many carbons? So let's count. 1, 2, 3, 4, 5. So we have a pentyne. Okay? This is a terminal alkyne. So this is carbon number 1, 2, 3. And the double bond occurs at carbon number 3. So we have 3-pentene 1-ine. But this is E because the priority group are of opposite sides. So this is the priority group and this is another priority group. So if you look at the hydrogen, you have a hydrogen upward and then you have a hydrogen downward. Clearly an E or a cis, no? Or a trans rather, an E or a trans, sorry. So this is either you call this trans 3-pentene 1-ine or E 3-pentene 1-ine. Now, what happens if they have equal, same position number, no? The double bond and the triple bond are of the same position number. Note that the double bond takes the lower number, but you still name using N, no? So this one is named, so this is now carbon number 1. So 1N, meaning the double bond is located at carbon number 1. 6-ine, the triple bond is at carbon number 6. And hep, meaning there are 7 carbons. So we have hept 1N 6-ine or 1-heptene 6-ine. What happens if there are multiple double bonds and multiple triple bonds? So again, we start numbering near the multiple bond, whether double or triple. So we start numbering here. So this is carbon 1. And there are 10 carbons. So 1,5-decadiene. So double bonds are at carbons 1 and 5. And triple bonds are at carbons 3 and 7. So we have 1,5-decadiene, 3,7-diene. Or deca 1,5-diene, 3,7-diene. Now we have here another example. So we start numbering from the side nearer the double bond. So this is carbon 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 carbons. So we have 7 isopropyl. There is an isopropyl attached to carbon number 7. 2N, the double bond is at carbon number 2. 5-ine because the triple bond is at carbon number 5. E antigen because the priority groups are of opposite sides. So this is the double bond. So there is hydrogen here. There is another hydrogen here. They are of opposite sides. Or if you look at the priority group, this is the priority group, one priority group, and this is the other priority group. Obviously, they are of opposite sides. So we have E. E7 isopropyl non 2 and 5-ine. This one, the next example, is a terminal alkyne. Therefore, we have here carbon number 1, 2, 3, 4, 5, 6. So we have a hexane, but we have a cyclopropyl attached to carbon number 5. So we have 5 cyclopropyl 1 hexane or 5 cyclopropyl hex 1-ine. This time, we have a double bond here. So double bond should take the lower number. So this is now carbon number 1, 2, 3, 4, 5, and 6. And therefore, we name this as 2 cyclopropyl 1 hexane 5-ine or 2 cyclopropyl hex 1 and 5-ine. Now, what about if we have a cycloalkyne? Okay, observe that the triple bond is always between carbon 1 and 2. So, palaging ganon, yung triple bond or double bond for that matter, palaging carbon 1 and 2 yun. So, didesisyonan mo lang kung sino si carbon 1 at sino si carbon 2. So, in this group, in this example, we can assign this as carbon number 1. So, 1, 2, 3, 4, 5. Or we can assign this as carbon number 1, 1, 2, 3, 4, 5. Any which way, pareho lang no, na may 3 tsaka 5 na substituent. Ano nang i-consider natin dyan? So, we will consider which comes first, methyl or propyl. Methyl comes first in the alphabet, so it should take the lower number. So, this should be named, so numbering now should start here. 1, 2, 3, such that this should be named 3-methyl 5-propyl cyclopentine. Now, here we have triple bond and double bonds. As we mentioned earlier, the double bond should take the lower number. So, we could start numbering here, assign this as carbon number 1. So, let's find out. 1, 2, 3, 4, and so on. So, the triple bond will have a high number. So, let's try assigning this as carbon number 1. 1, 2, 3, 4, 5. And then the triple bond is lower number. So we should number this, assign this as carbon number 1. And then we have the substituents ethyl, isobutyl, and methyl. I is considered because iso is not a prefix, so it's really the name. So the appearance should be ethyl, isobutyl, and then methyl. Looking at the locants, so we have ethyl group attached to carbon number 8, isobutyl attached to carbon number 10, and methyl attached to carbon number 7. So we call this 8 ethyl, 10 isobutyl, 7 methyl cyclodeca, 1 3 and 5-ine. The double bonds are at carbons 1 and 3, triple bond at carbon number 5, cyclo, because this is a cycloalkyne. And then just locate the substituents. Alright, so here we have another example of the existence of triple bond and double bond. I cannot see the cursor again. But we start numbering from the double bond nearer the triple bond. So that is carbon number 1. Alright, here. So this is carbon number 1, 2, and 3. Okay. So we have 8 carbons. So this is cyclooctane. No? Since there are 2 double bonds, so we have 1 6-diene. The double bonds are at carbon 1 and 6, carbons 1 and 6. The triple bond is at carbon number 3. And then we alphabetize the substituents. So we have dimethyl, ethyl, tertiary butyl, and propenyl. So I used red ink to compare the first letters which should be considered. Obviously, we start with butyl. We do not consider the prefix tert in alphabetizing. So we have tertiary butyl, which should appear first, and then we have ethyl, dimethyl, and then propenyl. So we call this 8 tert butyl, so hyphena, tert butyl, hyphen 7, hyphen ethyl, hyphen 1, hyphen propenyl, hyphen 5, 5, hyphen dimethyl cycloocta, hyphen 1, 6, hyphen diene, hyphen 3, hyphen ine. Okay? So let me repeat that. The name is 8 tert butyl, 7 ethyl, 1 propenyl. So this is an alkenyl. No, 1 propenyl, 5 dimethyl cycloocta, 1 6-diene, 3-ine. So basically, you should be able to recognize the alkyl groups, the alkenyl groups, and the alkyl groups. No? Alright, and then we have the last example. So clearly we have a cyclohexane. There is only one triple bond here. So this is a cyclohexane. So how do we number it? This can be carbon number 1, 2, 3. Or we can have this as carbon 1, 2, 3, and so on. But if we use this as carbon number 1, this will have a higher number. And there are 2 substituents. So we should name this as carbon number 1, 1, 2, 3. And we have a methyl group in carbon number 3, 4, 5, 6, and carbon number 6. Okay? And then we have an ethynyl group attached to carbon number 3. So we call this as 3-ethynyl because it comes first in the alphabet. 3-ethynyl. So we have an alkyne as a substituent. So we have 3-ethynyl, 3,6-dimethyl cyclohexane. So that's the name of the molecule. So thank you, and I hope you have a clear grasp of how to name alkynes. So basically, you just follow the rules, which have been outlined in the lecture. And of course, you should be able to recognize the substituents attached to the alkynes, whether the substituents are alkyl, alkenyl, or alkynyl. Okay? So see you next time. I hope you stay safe and stay healthy, class. See you when I see you.